Hi guys, sorry it's been so long, but I'm back. I was busy moving and stuff, so as you could tell by the new background. But today we're doing minimum cost to connect sticks. So we have some number of sticks with positive integer lengths. These lengths are given as an array called sticks, where sticks at I is the length of the ith stick. And we can connect any two sticks of lengths x and y into one stick by paying a cost of x plus y. We must connect all the sticks until there's only one stick remaining, and they want us to return the minimum cost of connecting all the given sticks into one stick in this way. So if we take a look at example 1, we're given this input array of sticks equals this, and we would output 14 because we start with sticks equals this array, and then the first step is we would combine sticks 2 and 3 for a cost of 2 plus 3 equals 5, and then we would remove both of these from here and add back the sum of the two, which is 5, and so we would have sticks equals 5 and 4. So then we would combine sticks 5 and 4 for a cost of 5 plus 4 equals 9. So then we would have just sticks equals 9. And then since there's only one stick left, we are done. So the total cost is 5 plus 9, which is 14. So in example 2, we have sticks equals this input array. We would output 30 because we would start with sticks 1 and 3 for a cost of 4. And then we have this array. And then when we combine 4 and 5 for a cost of 9, then we'll have this array. And then we combine 9 and 8 for 17. And then we have just sticks equals 17. And then since there's only one stick left, we are done. So the total cost is all of these costs added up, which is 30. So in example 3, we have sticks equals just this array of only 5, and then we would output 0 because since there's only one stick, we don't need to do anything, so the total cost is 0. So if you guys notice a pattern here, we are basically repeatedly adding two numbers from the array, from the input array, and it's always the two smallest numbers. So first we start with 2 and 3 in this case, which are the smallest numbers, and then we do 5 and 4 because these are the only two left, and we continue doing this until there's only one stick left, and then we would return the cost. And same with example 2, right? So we start with 1 and 3 because these are the two smallest sticks, because we want the minimum cost, and the cost is all of the numbers from each stick added up together. So we want to add all the smallest ones that we can at any given point, right? So we're just repeatedly finding the smallest ones until we only have one stick left. And every time we add a stick to the cost, we need to have like a cost variable that keeps track of this. That's going to be like a running sum, which is what we're going to return in the end. So we're going to do this with a priority queue because anytime you have like you repeatedly need to find the min or the max of an array, then a priority queue is going to be a good bet. So we're going to do a min heap. So priority queue of integers. We'll call it heap. Is going to be a new priority queue. And then we're just going to add all of the sticks into our heap. So for int stick in sticks, heap.add stick. Okay, and then if we use example 1 as an example, then we have sticks equals this input array. And then again, so keep in mind, disclaimer, this is not actually how heaps are implemented, but just for making it easy to look at, then this will be the sorted array. So I'm naming this sorted instead of heap because this is not actually the heap. So just keep that in mind. But like it just makes it easier to like think about it. Okay, so then once we've added all of our sticks into our heap, so we should always be able to find the minimum at any given point, then we want to loop through the heap and start adding up our costs and our sticks. So we're going to have a running sum for cost, which is 0. And then we're going to, if you guys remember, we continue going until we only have one stick left. So while our heap's size is greater than 1, then we're going to keep adding stuff. So we'll say they want us to add 2 sticks of length x and y. So the first one we can call it x. So x is heap dot remove. So the first round, this would be 2. Then we want to do the next one as well. So int y is heap dot remove, which would be 3 for example 1. And then like these would get removed basically, so then it would look like this. And let's pull this down so we have more space. Okay. And then we want to add both of these to the cost, remember? So like in example 1, when we removed 2 and 3 from this array, we have a cost of 5 now. So we're going to say cost plus equals x plus y. So we're going to add 2 and 3 to the cost, which was 0. So now the cost is going to be 5. And then we also want to add back the cost into the heap. Well, not the total cost, but like this cost of x plus y. So we're going to say heap.add x plus y as well. So then we're going to add back 5 into the heap, and then now the heap will look like this basically. Well, not really, but like, you know what I mean. Okay, then if we do another loop, then the heap's size is still greater than 1, so we'll do another loop. And then int x will be the top one from the heap, which is 4. Then y will be the next one, which is 5, so now the heap is technically empty. Then we'll add up the cost. So it was 5, then we're adding 4 plus 5, which is 9. So then the cost becomes 14. And then we need to add x plus y to the heap. So x plus y is 4 plus 5, which is 9. So we're adding 9 back into the heap, so then it's going to be like that. And then now the heap's size is 1, so we exit the loop. And then once we exit the loop, we just want to return the cost, which is now 14. And as we can see, that is exactly what we wanted. So let's test that. All right, so the time complexity in this case is going to be, so if we take a look at what we're doing here, right? So first we loop through all of our sticks and we add each of them into our heap, which is in this loop. And so every time we add something to a heap, that's going to be log n, because the heap needs to like look for the minimum or maximum, but minimum in this case, to put to the front and like sort it in its own way. So that's log n. And then since we're doing that for n sticks, then it's going to be O of n log n for this part. So this is n log n. Okay, let's move on. And then the next part, we are looping through the heap to basically like remove and add back sticks to calculate the cost. So we're doing this until the heap's size becomes 1 in this loop, which is going to be O of n basically, because it's like for n sticks again, well n minus 1, because we're only leaving like 1 stick left. But then there's just O of n. So far, like this is O of n, and then we need to look at what we're doing inside of this O of n. So every time we remove, that's log n. Every time we remove here, that's log n. So we have log n plus log n. This is constant because it's just a simple addition. This is the log n because it's adding to a heap. So basically 3 log n, which is just log n, and then for n times, then that's going to be n log n. So then if we add these two up, then n log n plus n log n, it just simplifies to n log n. So that's that. And then n is the number of sticks. Okay, space complexity. So we only have one data structure here, which is the priority queue. And as we can see here, or as we already kind of went over here, we are adding n sticks into our heap. And so this is just going to be O of n, where n is the number of sticks. And then down here, even though we're like removing and adding and stuff, like until there's only 1, we still at one point stored n sticks. So we'll just like we'll just call it n. But that is it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye.